So today I'm going to be explaining average velocity versus instantaneous velocity. So here we have a position versus time graph and an object that moves away from the starting point, back towards, and then away again. So if we have a car going, it would look kind of like this. Now I'm going to assign values to the graph. So at 2 seconds, the car reaches 20 meters away from the starting point. And then at 12 seconds, the car reaches 40 meters away from the starting point. Now the question we are trying to solve is what is the average velocity of the car between t equals 2 seconds and t equals 12 seconds. So to find the average velocity, we're going to do the change in position over the change in time. So x can also be the position. So we can see the change in the position is 20 meters from 20 to 40. And the change in time is 2 to 12 seconds. So the change in time is going to be 10 seconds in total. So as you can see, the average velocity is going to be positive because even though the car goes away and back towards and then away again, on average it is moving forwards. So now we can plug it into the equation, 20 meters over 10 seconds, and then we'll get an average of 2 meters per second between time 2 and time 12. So to find the average velocity between 2 points, we're going to take the change in the position over the change in time. To kind of go more into the definition, the average velocity is the slope of a segment or secant line connecting 2 points on a position-time graph, and that's going to be the average velocity over that time interval. But what would you do if you wanted to find the velocity at a specific time, like right at the green dot? This velocity is called instantaneous velocity, and it is a velocity at a given moment, or the rate of change of position for a time interval which is very small or almost zero. To find this, you're going to find the slope of the tangent line at a point, or the derivative of that point. Now let's try a problem. We have an object is moving along a line with position function s of t equals t squared plus 1. Here I am drawing a position time graph for this function. As you can see, the function slopes upwards. Part A asks us to find the object's position at t equals 1. We can use the graph to find this, but we're going to plug into the function instead. So we have s of t equals t squared plus 1. So we can plug in 1, so it'll be s of 1 equals 1 squared plus 1, which equals 2. And that works out well for the graph because like you can see at t equals 1, we have position 2. So we'll get 2 meters per second. I forgot to write in the units, but I'm going to write them in later. Now we have question B. Question B asks us to find the object's average velocity from t equals 1 to t equals 2. And we know from before that average velocity equals change in x over change in y. So if you look at the graph, we're finding the slope of the pink line or the secant line between the 2 points. Because we already have the value of s of 1, we have to find the value of s of 2. So we're just going to plug that right into the equation, and we get s of t equals t squared plus 1, just from the equation from the problem, and then we're going to plug in 2, so we already have s of 1, so now we're going to plug in 2, so s of 2 equals 2 squared plus 1. So now we're going to get s of 2 equals 4 plus 1, and s of 2 equals 5. And that also matches up with what our graph says. So now to find the average velocity between t1 and t2, we are going to do t2 minus t1, so 5 minus 2, 5 minus 2, and then, so the position over the time, and the time is going to be 2 seconds minus 1 second. So then we're going to get 5 minus 2, which is 3, over 2 minus 1 equals 1, so we are going to get 3. So the average velocity between t equals 1 and t equals 2 equals 3 meters per second. And I forgot to add the units on the values, so I am doing that now. Part C asks us to find the object's instantaneous velocity at t equals 1. To give a better visual for this instantaneous velocity, because it can be pretty tricky, I'm just going to draw out the graph again. So here are our points, here's our function. Connect them with blue. And then the pink between t1 and t2 is going to be the average velocity, so that's the slope of the secant line between the 2 points. And the instantaneous velocity is going to be here in green, and that's going to be the tangent line at t1. So that's going to be the instantaneous velocity. And it's going to give us the velocity at that specific point. Back to question C, we are trying to find the instantaneous velocity at t equals 1. So we're going to take our function s of t equals t squared plus 1, and then we are going to take the derivative of that function, which is going to be 2t using the power rule plus 0. Because it's at t equals 1, we are going to plug in 1 for t, so s of 1 equals 2 times 1 plus 0, or equals 2. So the instantaneous velocity at time equals 1 equals 2 meters per second. So to recap, the average velocity is going to be using 2 points and doing change in x over change in y, or change in position over change in time. And instantaneous velocity, it's going to be the velocity at that specific point, and you're going to use the derivative of the equation, and you're going to plug in the values to find the instantaneous velocity. And the instantaneous velocity is going to be the slope of the tangent line at that specific point. Average velocity, again, will look like this on a graph between the 2 points, and the instantaneous velocity is going to be the tangent line and will look like the pink line. Thanks for watching!